Welcome to the Extraordinaire. So just like I said, I'm going to be learning Python and I'll be documenting my progress while I'm learning. And one of the things that I like to do when I am learning anything new is I like to go to the source and look for a tutorial or a guide that can help me get my feet wet in the process of learning. So I found this really nice tutorial on Python's website, and I'm going to be going through that tutorial. So you can come along with me as I learn Python. I'll just be highlighting some key things that pique my interest. You could follow along with me, or you could also go on the website and open it up yourself and go through it. So let's get to it. This is the documentation. The first example that we are using is an informal introduction to Python. Feel like this is just giving us the basic types in Python. Let's take a look at it. So we have some examples here using Python as a calculator, and I think this is pretty straightforward. So if you add 2 plus 2 you get 4. That's using the terminal. So let me open up the terminal on the side here so that I can easily reference it when I need to. I'll open up the Python terminal. So I do 2 plus 2, it's 4. 50 minus 5 times 6, it gives us 20. 50 minus 5 times 6 divided by 4, we get 5.0, and 8 divided by 5 is 1.6. It's just like you do in regular maths. All mathematical symbols map to each other. I think the only difference is the asterisk symbol that maps to the multiplication sign. The integer numbers, I'm reading through this. The integer numbers, e.g. 2, 4, and 20, have a type of int, just like we do in PHP. The ones with fractional parts, 5.0, 1.6, have a type of float. Same thing with PHP. I think there are a lot of similarities between Python and PHP. Both programming languages are loosely typed, and I think that's another reason why I was drawn to Python, because of its similarity with a language that I already know, which is PHP. Here it says the division, which is this forward slash, always returns a float. So to do a floor division and get an integer result, you can use the forward slash operator to calculate the remainder. You can use what we in layman's terms refer to as the percentage sign. What this is saying is that if we do a fractional calculation, so for example, just like we see here, 17 divided by 3, it's supposed to give us 5.666666. But say we don't really care about the 0.666 part, we are just interested in how many times 3 can go into 17. The whole number, in other words, is what we are interested in. We can just use double forward slash, and that gives us 5 without the decimal numbers. And if we want the remainder instead of the actual dividend, we could do 17 and 3, and that gives us 2. This is something neat that I'm seeing with Python. With Python, it is also possible to use the double asterisk operator to perform powers. If you want to get the 5 raised to power 2, 2 raised to power 7, and so on and so forth. So if we do 5 double asterisk 2, that's 5 raised to power 2, which is 25, and we do 2 double asterisk 7, that gives us 128, which is really nice. The equal sign is used to assign a value to a variable. Afterwards, no result is displayed before the next interactive prompt. So if we do width equal to 20, height equal to 5 times 9, then we can say width times height is equal to 900. This is really nice. Now, if you're wondering what a variable is, a variable is just a memory location. Just think of it as a place to temporarily hold data that you need to use in your programs. If a variable is not defined, that means it's not assigned a value. Trying to use it will give you an error, which makes sense. It's like trying to access a memory location that you've not defined. It's not going to, you're not going to be able to get it. Or it's like trying to call a phone number that does not exist. You won't be able to call the number. There is full support for floating point operators with mixed type operands. Hold on. Operators with mixed type operands convert the integer operand to floating point. Oh, I see. What this is saying is that if I do an operation like 4 times 3.75 minus 1, now in this operation we have an integer, and then we have a floating point number, and we have another integer. Now what this is saying is, at the end of the day, we are going to get a floating point number, even though this number could be represented as just 14, which is an integer. It converts everything to a floating point number, and I could see why, because it's very possible that this operation could lead to a floating point. So it could be 14.2, right, if the right values were used instead of what we have here. So for example, let's say we do something like 4 times, let's say 2.13. What do we have? We have a floating point number. So makes sense that when there is a mixture of numbers, it's converted to a floating point. But let's see if we do just integers, whether it will be converted to a floating point. No, it is not. So that's really nice. In interactive mode, the last printed expression is expressed in the variable underscore. This means that when you are using Python as a DEX calculator, it is somewhat easy to continue calculations. For example, let's say we clear our screen. Hold on. I want to exit from here and clear my screen because we've had a lot of items there. Then I'll just enter the Python terminal again. Alright, we do tax equal to 12.5 divided by 100, then price equal to 10.5, or rather 100.5, price is times tax is 12.5625. What this is saying is, as we've calculated this 12.5625 is stored in the underscore value. So we could just do price plus underscore, and we get 113.0625, which is the same thing as doing price times tax plus price. The underscore held the value of price times tax, which we did initially here, so that we could easily access it in this subsequent interactive prompt. Make sense? This variable should be treated as read only by the user. Don't explicitly assign a value to it. You would create an independent local variable with the same name, masking the built-in variable with its magic behavior. Okay? In addition to int and float, Python supports other types of numbers such as decimal and fraction. Python also has built-in support for complex numbers and uses J or J suffix, that is lowercase j or uppercase J suffix, to indicate the imaginary part, e.g. 3 plus 5j. Okay, that's that's complex numbers maths, and I was really dozing off in math class when they were teaching that one. So let's proceed. The next type is text. Python can manipulate text represented by the type str, so-called strings, as well as numbers. This includes characters like the exclamation mark, words like rabbit, names like Paris, sentences like got your back, etc. Yeah. They can be enclosed in single quotes or double quotes with the same result. Paris rabbit got your back. 1975. Digits and numerical enclosed in quotes are also strings. This may be a little bit confusing for someone that is not aware. This 975 and 975 in quotes are not the same type. The first one is an integer, while the second one is a string. The first one is treated as a number, while the second one is treated like a text. So this is something that you should be aware of. To quote a quote, we need to escape it by preceding it with a backward slash. Alternatively, we can use the other type of quotation mark. If we want to put a quote within a quote, for example, we say we want to have doesn't, but now there is a single quote inside of doesn't. We need to put a forward slash, or rather a backward slash, before the quote in between the two quotes. So if we do that, so we have backward slash and then the quote, then the single quote appears in the text like this. But if we should do it without the backward slash, this is what we get. We get a syntax error, which is not what we want. Another way that we can make this doesn't to show the single quote to show up is to use the other type of quotation, which is the double quote, and then have the single quote inside of that, and then we get the single quote displayed. Make sense? In the Python shell, the string definition and output string can be different. The print function produces a more readable output by omitting the enclosing quotes and by printing escaped and special characters. We have s is equal to first line backward slash n, second line, and full stop. This is going to separate these two texts into this backward slash n will separate these two lines of text into separate lines. So let's see how that works. If we should enter this, it prints it normally, but if we should use print s instead, the two lines are separated into separate lines. That's how print is special in the interactive shell. If you want characters prefaced by forward slash to be interpreted as special characters, you can use raw strings by adding r before the first quote. If we have this, print C some name, this prints some name, but notice that the name part is being moved to the next line. But let's say we want to have them on the same line because we are trying to access some sort of directory on the system or a file path on the system. We would like to have this string displayed exactly the way we typed it. So the way to make that happen is to use R in front of the string. So we do it like this instead. R C colon / some name, and then we have it. It's really nice. There is one subtle aspect to raw strings. A raw string may not end in an odd number of / characters. Wow. See the FAQ entry for more information and workarounds. We'll get around to that. String letters can span multiple lines. One way is using the triple quotes or triple double quotes or triple single quotes. End of line characters are automatically included in the string, but it's possible to prevent this by adding / at the end of the line. In the following example, the initial new line is not included. Alright, so let's see. For example, we have print triple quotes, then we say usage thingy options, -h -h that's lowercase h. So display this usage message, and then uppercase h is host name, hosts name to connect to. Okay, then we have the triple closing, right, and this displays multiple lines of text. Really nice. This triple double quotes or triple single quotes, it's more text, like it doesn't take as much text, which I'm noticing is a pattern with Python. Most of the syntax requires little text to achieve. It's more like shorthand. Strings can be concatenated, basically glued together with the plus sign and repeated with the asterisk. We could have 3 times on plus and that gives us ununium. Interesting. For example, I think we could do something like bar plus na times 2, which would give us, you guessed it, banana. But this is really nice. I could imagine a couple of places where this would come in really handy. 2 or more string literals, that is the ones enclosed between quotes next to each other, are automatically concatenated. So what this is saying is, if I have 2 texts like this, 2 string literals like this, it's automatically concatenated. Really nice. This feature is particularly useful when you want to break long strings. So we want to say text is equal to put put several strings within parentheses. Okay, and we can move to the next line and to have them joined together. And when we put it in text, they are joined together. But what this means is that these things have to be in parentheses for them to be joined together, because we're assigning it into a variable. Let's see what happens if we try to do this without putting the parentheses. What happens? Text is equal to I am testing a feature of Python. Let me try displaying right, so it just displays only the let me take this up a little. It just displays only the initial text, I am testing. It doesn't display the rest. Okay, this terminal is getting full. Let me reduce it. Exit from here. I wonder if there is a way to clear this Python terminal without having to exit and then go back in again. Python 3. Perhaps we'll find out while we are going through the video. So this only works with two literals, not with variables or expressions. Okay, makes sense. So if we do Python equal to prefix and then prefix and thorn, they can't be concatenated. And if we do this times 3, they can't also be concatenated. Now if you want to concatenate variables or a variable and a literal, you have to use plus. Yeah, just like we saw earlier here, we have to use plus to concatenate a variable and a string literal. Strings can be indexed, subscripted, with the first character being 0. There is no separate character type. A character is simply a string of size 1. Interesting. So if I have, for example, word equal to Python, hold on, that's not a string. Word equal to Python, we have to put it inside quotes for it to be a string, and I say word 0. This gives me the first letter of the word. Now if I should say 2 4 6 word 6, it can't be. Why? Because it's 0 indexed, meaning that we start with 0 and then we end at 1, the length of the word minus 1, which means the highest I can go is word 5 to get the last letter of the word. Very cool. Now indices may also be negative numbers to start counting from the right. So if we do -1 instead of 5, we could get the last letter, and second to the last letter will be -2, and then the first letter you can also arrive at that with -6. Note that since -0 is the same as 0, negative indices starts from 1. Okay, but what happens if I put -0? Let's try it. It still gives us it still gives us the first letter. Okay. In addition to indexing, slicing is also supported. While indexing is used to obtain individual characters, slicing allows you to obtain a substring. Word 0 column 2, characters from position 1 included to 2 excluded. This is going to give us the character starting from the 0 index up to but not including the 2 index, which is the third character. We say 0 to 2, so we do up to but not including the third character, and that gives us pi. Very nice. And if we do the same thing for 2 up to 5, that gives us THO. Makes sense. Slice indices have useful defaults. An omitted first index defaults to 0. An omitted second index defaults to the size of the index being sliced. Interesting. So for example, if we do column 2, we get pi, and then if we do 4 column, we get on. So this means that this column 2 is the same as 0 2, and column 4 and 4 column is the same as 4 6, right? Really cool. I think I'm loving the syntax, the Python syntax so far. Note how the start is always included and the end is always excluded. This makes sure that S column I plus S I column is always equal to S. Okay, interesting. I guess what this is saying is, if we start with 0, for example, the 0 index would always be included, and if we end with say 6, the 6th index would not be included. And the reason for that is so that word column 2 plus word 2 column would always give us the entire word, right? Which makes sense because word column 2, this is the same as saying word 0 column 2 plus word 2 column 6 to column 6. And in this case, we are starting from the first index, which is P, up to the third index, which is T, up to but not including the third index, which is T, and that is going to give us PY. Now here we are starting from the third index, from the third word, from the third letter, sorry, which is T, and up to the 6th letter, which does not exist, right? But that is not being included, so that will be left out. So when we do this, we get THON on this end and plus PY on this end, and that gives us the full word, which is the same as what we had initially. Really neat. Oh, right. Okay, so this is an explanation of what I just did here. So one way to remember how slices work is to think of indices as pointing between characters with the left edge of the first character numbered 0, then the right edge of the last character of the string of n characters has index n. For example, so we have 0 1 2 3 4 5 6, okay, and 6 is at this point, 5 is n, 4 is 0, 3 is H, 2 is T, 1 is Y, and then 0 is P. Makes sense. The first row of numbers gives the position of the 0 index 0 to 6 in the string. The second row gives the corresponding negative indices. The slice from I to J consists of all characters between the edges labeled I and J respectively. For non-negative indices, the length of a slice is the difference of the indices if both are within bounds. For example, the length of the word 1 column 2 is 2. Attempting to use an index that is too large will result in an error. Yeah, we've already experienced this. Let's proceed. However, out of reach slice indexes are handled gracefully when used for slicing. Oh, okay. So if I do 4 word 4 column 42 on interesting, starting at the 4th index, which is the 3rd letter. Is that the 3rd letter? The 4th index. Let's check our listing again. No, the 4th index is the 5th letter, which is hold on, 0 1 2 3 4 1 2 3 4 5. Yeah, the 4th index is the 5th letter, which is O. Okay, and that gives us ON, and then the upward bound is not, it's just not considered, I think. Interesting. So if we should start at 42 instead, because it is out of bound, it just gives us an empty string. That's nice. Python strings cannot be changed, they are immutable. Therefore, assigning to an indexed position in the string results in an error. So I cannot go in and say, for example, word 0 is equal to J. Wow, that would have been cool though. I wonder why that was limited. Okay, if you need a different string, you should create a new one. So yeah, I guess that makes sense. So if we want to create a new string, we could just do J and then use the plus sign to concatenate the word starting from 1 and up to the end of the word. Okay, up to the end of the word. Makes sense. The built-in function len returns the length of a string. So if I say s is equal to, I don't want to spell that word, so I'm going to use extra judicious. I hope that's correct. Len s gives us 14. Let's count. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, so that's correct. So len gives us the length of a string. We'll continue with lists in the next video. This video is already long enough. So if you enjoy this, you like this style of tutorial, if you will, because I'm just learning and you're learning along with me, you could like and subscribe, share with anyone that you think would also find it interesting, and see you in the next one. Bye.